Okay, so our very first term is going to be 4 because that's the power, choose 0. So we have 2 to the x raised to the 4th power, negative 1 to the 0 power, and then plus. We're going to have 4 to the 1, 2 to the x to the 3rd power, negative 1 to the 1 power. My next term is going to be 4 choose 2, 2 to the x squared, negative 1 squared. My next term is going to be 4 choose 3, 2 to the x raised to the 1 power, negative 1 raised to the 3rd power. My last term is going to be 4 choose 4, 2 to the x to the 0 power, negative 1 to the 4 power. What do you notice about my powers? What do you notice about these powers and these powers and these powers? They always add up to 4. So it always adds up to whatever your expansion is. So if you're expanding out to the power of 7, those exponents have to add up to 7. All right? Now, if you're thinking, man, I'm really loving this whole choose thing, well, I'm sorry to inform you, we're going to make it easier for you. But if you love the choose thing, just don't listen. So if I did something to the 0 power, so I have x plus 1 to the 0 power, what does this equal? If I have x plus 1 to the 1 power, what does that equal? That equals x plus 1. What are the coefficients on there and the constant? What if I asked you to do x plus 1 squared? What does that multiply out to? What are the coefficients and the constants? What if I asked you to multiply x plus 1 to the 3rd power? You have no idea, but I'll show you how to do it. Notice, if I add these two numbers together, I get the number 2. So using that same pattern, my next row would be 2, 3, 3, 1. The way I got that was these two give me 3, and these two give me 3, and ones are on the diagonals. So what does this expand out to? It expands out to x to the 3rd plus 3x squared plus 3x plus 1. My exponents on the x's are going down by 1. My exponents on the 1's are going up by 1. If I wanted to expand out x plus 1 raised to the 4th power, I'm going to come over here and I am going to write out this next row. So 1, 4, 6, 4, 1. So this is going to expand out to x to the 4th plus 4, x to the 3rd plus 6x to the 4th, squared, plus 4x plus 1. And I don't have to choose anything. Isn't that sweet? This is called Pascal's triangle. So Pascal's triangle starts with a 1. That represents my binomial to a power of 0. My next row is 1, 1. These are the coefficient multipliers when I have a binomial raised to the power of 1. My next row is 1, 2, 1. Those are my coefficient multipliers for when I have x plus 1 squared, or a binomial squared. My next one is 1, 3, 3, 1. That represents my binomial. These are just multipliers. That it represents my binomial with a power of 3. 1, 4, 6, 4, 1. That represents my binomial expanded out with coefficients. These are just the coefficients that are given to me. That's it. These are the coefficients when I expand out with a power of 4. If you're not really sure where you are, like I don't know which row to use, this tells you what the power is. This is a power of 4 row. This is a power of 3 row. This is a power of 2 row. So if I wanted to do a power of 5, then I'd have 1, 5, 10, 10, 5, 1. That's a power of 5. Now let's apply that to C. What I'm going to do, because it's a power of 4, is I'm going to use the row on the Pascal's triangle that has a power of 4, and I'm going to just write my coefficients first, and I assume it's always plus. So I'm going to start out with a coefficient is 1. My next row on a power of 4 is 4. 1, 4, 6, 4. So I'm going to give myself space. 1, 4, 6, 4, and then 1. All of those numbers just represent the coefficients. Now, because you all told me that my powers are adding up to 4, my first term has to be a power of 4 for the 1. So I'm going to write all of my 1s or my A position. So I have 1 to the 4th, 1 to the 3rd, 1 squared, 1 to the 1, 1 to the 0. Do I need to stop? I can stop for a minute. Make sure we're all on the same page. All right. Now, I'm going to do my 2i. 2i to the 0. Because remember that 4 plus 0 has to add to 4. 2i to the 1. 3 plus 1 is 4. I'm good there. 2i squared. 2 plus 2, my powers add up to 4, so I'm good. 2i cubed. 1 plus 3 is 4, so I'm good. And 2i to the 4th. 4 plus 0 is 4. And there is the binomial theorem in all of its glory, the short way. But if you're like, man, I really like writing the choose, knock yourself out. Let's just clean this one up so we can be done with it. So cleaning this up, I have 1 times 1 to the 4th, which is just 1. 2i to the 0 is still just 1, so this first term is just 1. My second term is 4 times 1 times 2i to the 1. So this is going to give me plus 8i. All right? Plus 8i. My next term is going to be 6 times 4i squared. Don't forget to square that 2 and the I. So my next term, this one right here, is going to be 6 times 4i squared. But what is I squared? Negative 1. So this really is minus 24. My next term here is the same thing as 4 times 8i to the 3rd. So 4 times 3 is 32. What is I to the 3rd? Negative I. So this becomes minus 32i. My last term is going to be 1 times 0, or times 1 to the 0, and then 2i to the 4th. This last term is going to be 8i to the 4th, or 16i to the 4th. So what is I to the 4th? 1. So that's where we are. Now this is a complex number, so I have to write my final answer as a complex number, a plus bi. So I'm going to add all my non-I terms. So I'm going to add 1, negative 24, and 16. What is 1 minus 24 plus 16? What is it? 7, 8, 9? What is it? 7. And then I have 8i minus 32i. So I subtract off how many i's? What's 28 minus 32? There is all of my answer in its glory. How was that? How many of you are like, man, I really want to go back to the choose binomial thing? Okay, cool. I personally don't care how you do this one, right? On the test, there is one on the test. I'm letting you know right now. There is one on the test. I don't care if you do the Pascal's triangle off to the side. I don't care if you use the binomial theorem. Have you all looked at the formula sheet I provide for you? I provide that for you every single test so you know which things you don't have to worry about. Those are all, I give it to you every single test. All right? I have a laminated sheet. It's all ready for you. Is there any questions about expanding out the binomial theorem? Cool. Now, for this one, I want to find a certain term. I want to find the term that has 117 in it. I want to find the term that has 117 in it for the x power. How far in must I have gone? So I know if I were to expand this out with the binomial theorem, which I wouldn't normally, I would have had 118, choose 0. My exponent on the x would have been 118, then 2 to the 0. My next term would have been, my second term would have been 118, choose 1, and the power here would have been x raised to the 117. It is my second term in. And then 2 raised to the 1. The term that I want is that one, because that's the one that has x raised to the 117. So on your homework, it's going to ask you to do these certain ones. It's going to say, tell me which one has that term. So in this case, I know it's one of the special cases. I have 118, choose 1. What is 118, choose 1? 118. So this is going to be 118 x raised to the 117 times 2. So what I'm going to put in web work is a multiplication of 118 times 2, which is what is 118 times 2? So I'm going to put in web work 236 x raised to the 117. Does that make sense? Now notice, this is something to notice, that this is how I got to there, 118 minus 1. It is my second term, but it's 118 minus 1. I'm going to give you another one to practice before we go back up to that lovely one. I want you to do 2x minus 3 raised to the 17th, and I want the term that is x to the 8th. So I want the term that is x to the 8th. I'm going to have 17 choose what? Some say 8, some say 9, some say 42. 25 is much funnier. How do you know what to get for there? What number do I choose? Why is it 9 and not 8? 17 minus 8 is 9, so it is 17, choose 9. And then this is going to be 2x raised to the 8th power. And then negative 3 is going to be raised to what power? It's going to be raised to 9. All right? Those have to match up. 8 plus 9 must be 17. 8 plus 9 must be 17. And then whatever that equals. Whatever 17 choose 9 is. How was that? That's it. And then you would use your calculator and get the answer. All right. Now, let's go back to this one. First thing you want to do when you work on this one is you want to rewrite this here as x raised to the 1/2. I want to rewrite that as x raised to the 1/2. So then what you really have is x raised to the 1/2 minus 3 to the 8th power. So go ahead and now in that form, see if you can find the term containing x raised to the 7/2. So you have 8, choose 1, and then you have x raised to the 1/2 raised to the 7th power, and then you have minus 3 raised to the 1 power. This one I'm going to do because I can do it without a calculator. What is 8 choose 1?
8.
All day long. This is 8. So this is negative 3 times 8, so it's a negative 24 x raised to the 7 over 2, and that's your final answer. That's it. Boom. Done. How was these compared to some of the other stuff we've done so far? It's all easy.